Good morning, friends. I'm Shamila. Today we can discuss about stabilization ponds. The ponds designed and built for wastewater treatment to reduce organic content and remove pathogens from wastewater. These are man-made depressions confined by earthen structures. Influent enters from one side and effluent exits from the other side. After spending several days in the pond, the treatment process takes place. It is suitable for the warm climate countries. They are frequently used to treat sewage and industrial effluents. And municipal runoff or stormwater also can treat. The system may consist of a single pond or several ponds in series, each pond playing a different role in the removal of pollutants. After treatment, effluent may be returned to surface water or reused as irrigation water. The removal rates are slow. Larger areas are required. The ponds receive wastewater and stabilize it, so-called waste stabilization ponds. BOD values in the pond effluent are lower than in the influent, reflecting the removal of organic matter. This pond biome uses organic matter from the wastewater as food. Removal of pathogenic bacteria and viruses occurs mainly by inactivation. Pathogens are inactivated as a result of complex interaction of mechanisms that involve pH, temperature, UV radiation present in the sunlight that reaches the pond surface, and photooxidative reactions taking advantage of high dissolved oxygen concentrations. Waste stabilization ponds consist of man-made basins comprising a single or several series of anaerobic, facultative or maturation ponds. The presence or absence of oxygen varies with the three different types of ponds used in sequence. Anaerobic waste stabilization ponds have very little dissolved oxygen, so anaerobic conditions prevail. In facultative, they sustain an aerobic surface habitat above an anaerobic benthic habitat. Maturation ponds offer aerobic conditions throughout from the surface to the bottom. The main types of pond system are facultative, anaerobic pond followed by facultative pond followed by maturation pond in series, anaerobic pond followed by facultative ponds followed by maturation ponds in series. The image showing the series of that ponds. First one, anaerobic ponds. They receive raw wastewater. They have a smaller surface area compared to facultative ponds and are also deeper, 3 to 5 meter depth. Depth decreases the influence of oxygen production by photosynthesis, leading to anaerobic conditions. Depending on loading and climatic conditions, these ponds are able to remove between half to two-thirds of the influent BOD. They release malodorous gases. Ponds digest putrescible solids suspended in the wastewater being treated. Allow solids to settle down at the bottom as sludge. A large fraction of settled solid will accumulate close to the point where wastewater enters the pond. They are deeper. They contain anaerobic organisms which can break down complex organic waste into basic compounds. They can thrive in warm temperatures. Anaerobic ponds are not suitable in temperate or cold climates. Sludge accumulates at the bottom of the anaerobic ponds. Facultative ponds can be discussed now. They receive raw wastewater. They are called primary facultative ponds. If they receive wastewater that has already been treated in anaerobic ponds, they are called secondary facultative ponds. Facultative stabilization ponds may also be used for treatment processes such as upflow anaerobic sludge blanket, that is UASB reactors, oxidation ditches or aerated lagoons. They are shallower. The surface area allows atmospheric oxygen to dissolve and sunlight radiation to penetrate the water. Next is the maturation ponds. Some additional removal of organic matter and other pollutants may be achieved in maturation ponds. These are only included in the treatment line when high efficiency of pathogen removal are required. Either for discharge of the treated effluent in surface water bodies or for use of irrigation or aquaculture. They are usually used after facultative ponds but may also follow other treatment processes such as UASB reactors. They could also be placed after an inactivated sludge process. Maturation ponds must be shallow with a great surface area. Shallow ponds benefit from high photosynthetic activity arising from the penetration of solar radiation. pH values are high. Due to high surface area, protozoan cysts and helminth eggs are also removed with sedimentation as the main mechanism. Here, sludge accumulation is very low. That's all. Thank you.